Now, what we wanted to talk to you about on the show today is service mesh, but we can't dive straight into service mesh, right?
Sure.
Let's start. Let's zoom out a little bit in the world of networking and containers. Networking seems pretty challenging. I mean, with Kubernetes, it's very dynamic. There might be one or two or three layers of networks underneath Kubernetes. So, what sort of issues do you see people struggling with when it comes to networking in Kubernetes?
Yeah. So, it's not just Kubernetes. I think it's important to step back. And I think what I would say is that computer networking is complicated, period. It's just in the sense that it's a domain where things do fail. I think lots of times as software engineers, it is relatively easy to pretend that things don't fail, and I don't know that people make their software and systems robust enough to the failure that actually does happen. But in the domain of computer networking, it's just things fail so often that it's almost impossible to pretend that those types of failures don't occur. So I think stepping back, it's really that even in quote unquote simple computer networking, where you have fixed hosts and things like fixed IP addresses, you're still seeing failures. You're still seeing packet drops and hosts go offline and all of those types of things. I think the issue with Kubernetes and microservice deployments and I would say highly dynamic environments. So again, it's not really Kubernetes. You could have a a functional system like AWS Lambda or Google Cloud Run. Just the idea where we have resources that are coming and going, whether they're auto scaling, whether they're functions. And in these types of highly dynamic environments, the types of networking failures that one sees with things coming, things going, things failing, it's just the rate of those occurrences are so much higher. I mean, they're probably an order of magnitude or more higher. So
Hmm.
all of the edge cases that might have been, oh, I can kind of brush those under the rug. It's really impossible to brush those things under the rug. They just happen so often.
Well, we wouldn't have a
So
higher error rate, Matt. So do you mean higher in just the fact that there's so many more transactions going on that there's just proportionally more transaction failures?
Well, it's not even about the transaction failures. It's more about the fact that resources themselves are actually dynamic. So when it comes to auto scaling environments or auto scaling container environments, the rate of change, meaning let's say that I scale up and I scale down, and technologies like Kubernetes or other functional platforms, they're going to allow me to scale up and scale down more often in I would say in a finer response to load, and that more dynamic auto scaling and also the assumption that things can just come and go. So take a Kubernetes or a container deployment environment in which maybe I have two classes of jobs running. Maybe I have what I would call real-time jobs, and then I have what I would call batch jobs. So things like machine learning workloads or things where they can run in the background. You may actually design your system from a cost perspective to preempt or terminate the batch workloads if my real-time workloads have to run, right?
Hmm.
And so really, not only are the resources not fixed, but you're designing in failure. You're designing in the fact that your service topology may change at any particular time. So it's not just raw transaction failure. It's the fact that my entities on the network, even if the network, as was said before, is multiple layers of abstraction, it's layer upon layer upon layer, is the fact that these things can just come and go so often that routing problems happen,
Hmm.
networking problems happen. A host might drop offline in the middle of the network transaction. You might
Hmm.
have health checking failures. You might have all types of manner of failures. And your service discovery system, the system that tells you the topology that allows you to figure out, okay, what host can I route to? What host can I load balance to? That is also changing. So just the rate of change causes more pressure on the
Yeah,
system. It's just a more complicated environment.
like you happen to be talking to a bunch of network engineers that are probably listening to this show as well as cloud people,
Sure.
Matt. So, and when you mean networking, you're talking about a little higher up at the service layer stack. not like top of rack switches and cabling and that kind of stuff.
Correct. Right. Right. I'm talking about, yes, I'm talking about application networking. So things that would typically sit on top, really at typically the L3, L4 layer and above. So you're talking about an application that might come up at a particular IP address and a particular port, and maybe it's only up for 30 seconds and then it's down, right?
Yeah.
Mhm.
So we have this eventually consistent system that is always converging. And it's not that at the L2, L3 layer, it's not that things don't converge, using things like ECMP and BGP, et cetera. But those things are typically not the norm. They're in response to a particular failure. And what I'm saying is that in these highly dynamic, highly scalable application environments, this type of convergence is actually the norm. It's not just in response to failure. So whereas in a lot of the lower layer networking systems, some of the failures happen relatively infrequently, and maybe you can suffer a multi-second downtime. It happens so frequently in these application architectures that the bar to having it be lossless is higher.